What happens if you fall into a black hole? No one has ever survived to tell the story. No camera has ever crossed the boundary and sent footage back. And yet, physics gives us a terrifying answer. Imagine drifting through space, stars behind you, silence around you, and ahead, a region darker than darkness itself. Not a hole in space, but a place where gravity becomes so powerful that not even light can escape. If you fell in, what would you feel? Would you die instantly? Would you be crushed? Would you see the future of the universe before the end? Tonight, we're not just asking what a black hole is, we're stepping toward one, second by second, till there is no coming back. Part 1. What a black hole really is. First, let's clear something up. A black hole isn't a cosmic vacuum cleaner sucking everything in. It's an object, formed when a massive star collapses under its own gravity. When stars much larger than our sun die, they explode in a supernova. If the remaining core is heavy enough, gravity wins completely. It collapses to a single point of infinite density called a singularity. Around it forms a boundary known as the event horizon. Cross that boundary, and escape becomes impossible, not because something pulls harder, but because space itself curves inward. Inside that boundary, all paths lead deeper in. Even light cannot turn around, which means once you cross it, the universe can no longer see you. Part 2. Approaching the black hole. Let's imagine you're in a spacecraft approaching one. From far away, it might not look dramatic. You'd see stars bending around it. Light would warp in strange arcs, a phenomenon called gravitational lensing. Time would already begin to behave differently. From the perspective of someone watching you from far away, your clock would tick slower. The stronger the gravity, the slower your time moves compared to theirs. As you get closer, something unsettling happens. To distant observers, you appear to slow down. Your movements become sluggish. Your image reddens and fades. Eventually, you freeze at the edge, never quite crossing. But from your perspective, you move forward normally. You don't feel frozen, you don't feel paused. You cross the boundary without fireworks, without dramatic flash, just silently. And at that moment, you are alone in a region of space-time that no message can escape. Part 3. Spaghettification. Now comes the terrifying part. Gravity doesn't just pull, it pulls unevenly. Your feet being closer to the black hole feels stronger gravity than your head. This difference is called tidal force. And near a small or medium-sized black hole, it becomes lethal. Your body would stretch, pulled longer and thinner, atoms separating, bones elongating, organs tearing apart. Scientists call this spaghettification. You wouldn't simply be crushed, you would be stretched into a thin stream of matter, your body turning into a ribbon of particles spiraling inward. Death would likely occur before you even fully processed what was happening. But here's where things get stranger. If the black hole is supermassive, like the ones at the center of galaxies, tidal forces at the event horizon could actually be gentle. You might cross the boundary without feeling anything dramatic at first, which means you could survive crossing the event horizon. Temporarily. Part 4. Time breaks down it. Inside the event horizon, space and time swap roles. Outside, you can choose to move forward or backward in space, but time only moves forward. Inside a black hole, moving toward the singularity becomes as unavoidable as moving into the future. You cannot stop it. You cannot turn around. The singularity is not a place you travel to. It is a moment you were forced toward. As you fall, you might see something extraordinary. Because of extreme gravitational effects, light from the outside universe could appear compressed. You might witness stars aging rapidly, galaxies shifting, perhaps even the distant future of the cosmos flashing before you. In theory, you could see millions or billions of years unfold in seconds. But this depends on complex physics we still don't fully understand. Eventually, tidal forces increase beyond survival. and no known law of physics can describe what truly happens at the singularity, because our theories break there. Gravity and quantum mechanics stop cooperating, and reality itself becomes uncertain. Part 5. Does information die? For decades, physicists argued about something called the information paradox. If you fall into a black hole, does all information about you disappear forever? That would violate fundamental laws of physics, because information, in theory, cannot be destroyed. Some theories suggest black holes slowly evaporate through something called Hawking radiation, named after physicist Stephen Hawking. Over unimaginable timescales, a black hole could shrink and vanish. If that happens, what happens to the information about everything it consumed? Is it encoded on the surface, stored holographically, lost in another dimension? We don't know for certain. Which means falling into a black hole isn't just a death sentence. It's a journey into the limits of human understanding. Part 6. Could it be a portal? Science fiction loves the idea that black holes are gateways, portals to other universes, tunnels through space-time known as wormholes. Mathematically, wormholes are possible solutions in Einstein's equations, but stable, traversable wormholes, that's another story. Most models suggest anything entering a black hole meets the singularity, not another universe. Still, we can't rule everything out, because we don't yet have a theory of quantum gravity. So the truth is this: falling into a black hole takes you beyond tested physics, beyond observable reality, beyond the edge of knowledge itself. Part 7. The Final Moment. As you approach the singularity, tidal forces become infinite, density becomes infinite, curvature becomes infinite. Infinities in physics usually signal incomplete understanding, which means something deeper may be happening. But from your perspective, there is no heroic survival, no dramatic escape, just increasing distortion. Till the structure that holds you together ceases to exist, matter dissolves into extremes we cannot describe, and the universe continues without you. So what happens if you fall into a black hole? You cross a boundary where escape is impossible. You stretch under forces beyond imagination. You watch time behave in impossible ways, and you vanish into a region where physics itself breaks down. Black holes are not just cosmic monsters, they are laboratories of the unknown. If this made you rethink the universe, comment below. Would you step toward a black hole if it meant discovering the ultimate truth? Like, subscribe and stay curious, because sometimes the most terrifying places in existence aren't dark because they're empty. They're dark because they hide what we don't yet understand.